Okay, so yesterday we were talking about perimeter. Today we're going to talk about area. Right, so we should already know some things about area because we've talked about area in previous courses. We talked about it at the start of the trimester. Now, remember, my students will often say, well, area is length times width. But remember, every single figure has a different formula to find the area. Right? So the area of a triangle is like 1/2 base times height. So I don't want you to think what we're looking at today means that all formulas are the same. It's just that today we are going to be looking at overall at rectangles. Okay, so we should know that the area of a rectangle is the length times the width. Yeah. And just like we talked about yesterday, now our area is going to have lengths and widths that aren't just numbers, right? They're going to include some variables. Okay, so maybe if we have a rectangle, assume that I can draw perfectly. Maybe we have one side length that is 6x squared y, and one that is 2xy to the third. Okay, so if we want to calculate the area of this rectangle, just like our formula has always told us, we need to multiply the length and the width. So we need to multiply 6x squared y times 2xy to the third. Good news, we already know how to multiply these two things. Right? We started talking about this last week. We just reviewed it in the POD. Okay, so we'll multiply the coefficients. So 6 times 2 is 12.
X.
And then we'll add the exponents. So x's can go together. So 2 plus 1 will give us x to the third. And then 1 plus 3 will give us y to the fourth. So we would say that this rectangle has an area of 12x to the third, y to the fourth. We don't know its label, right? So some type of unit squared. We just don't know what it is.
That's easy.
Well, that one's easy.
Yeah,
Right.
that's easy stuff.
And again, as long as you know your rules of area, okay, and you know your rules of polynomials, it's not like we're adding a ton of new information today. They just start having more steps to them. Okay, so let's say we have a specific type of rectangle. This is going to be a square. Ooh. Okay, pretend I could actually draw a square.
That's a box.
Okay, so I'm telling you this is a square. All the sides are congruent. All 90-degree angles. Pretend all those things are true.
Wait.
Okay, so how do we find the area of a square? Dylan, what do you say?
Do you put them in like the parentheses and times them 4 times?
Okay, so not 4 times because we just want a length times a width. Now, we can find area of a square. We do have this formula that says area of a square, right? Length times width is fine, but the length and width are the same. So it's really a side squared. Okay, you can think about that either way. Either way with the square, we know that this other side is still a 2x plus 3. And so we want to take 2x plus 3 times 2x plus 3. Yes, Bailey?
Couldn't you also write as the 2x plus 3 in parentheses and then the exponent of 2 on the outside?
Right, just keep in mind that if we write it that way, so if we write this 2x plus 3 squared, this exponent of 2 tells us to write it twice and then to still multiply it out. So it's the same thing. We eventually have to get to that step because now we have to start distributing. Right, so 2x times 2x gives us 4x squared. 2x times 3 gives us
6x.
a positive 6x. And we'll distribute the 3 next, right? So 3 times 2x
Positive 6.
gives us a positive 6x. And 3 times 3.
Positive 9.
So we can combine like terms here and say that this square has an area of 4x squared plus 12x plus 9.
So we'll always do that for a square.
Mm-hmm.
So it's different with different shapes.
Well, a square is really still length times width. But right, if we had a triangle, it'd be 1/2 base times height. We're not going to look at the area of any triangles right now.
So this is all we're doing right now? No?
Kind of.
We can put that.
You'll see here.
Okay. Oh boy. That's a rectangle.
This is still a rectangle, right? It's long and skinny, but still a rectangle.
Wow.
Okay, so basically the idea here is that these side lengths can be anything.
Yep.
And I know I've repeated this every day. I'm going to say it again, right? Just because it looks different or it looks hard doesn't mean it is, because exponents have that same consistent property. Okay, which means it might take us a little bit more time, but the rules aren't changing on us. How do we find the area of a rectangle?
Length times width.
Length times width. So we want to multiply these two things. We have said when we multiply these two things that it's really ideal that we multiply with the smaller one in front.
Yep.
So we'll put the monomial in front.
Yep.
And the trinomial after it. Right? When we're multiplying something with multiple terms, the multiplication symbol that we want to use here is parentheses. This is something we know how to multiply, right? We just need to distribute.
Yes.
So we can now start distributing. So 2x times a 3x squared gives us what?
6x to the third.
6x to the third. Times a negative 4x gives us
Negative 8.
a negative 8x squared.
And then positive
2x times a 1 gives us a positive 2x. And so this would be the area of that rectangle. Right, so if the side lengths were both, right, one binomial, one trinomial, right, then we'd be taking a binomial times a trinomial, which we already know how to do. Okay, it just sort of grows based on all those multiplication rules that we've talked about. Here is where we have to be a little bit more thoughtful and intentional with what we do. So give me sort of a minute here to get this drawn out for you.
That's a rectangle.
That sure is a rectangle.
Happy birthday. That's another rectangle. Happy flavor. Oh, we're doing this now.
That's usually about the point my students realize.
Joking.
These guys.
No, I did this last year and I failed.
Okay, so, right. Most of us at some point in 7th and 8th grade should have done a lot with sort of the geometry pieces of finding area, finding perimeter, looking at the different formulas for finding those things, whether it be volume, surface area, right? Do you remember finding those nets where you like unfolded things? Right, lots of different things, thank you. Lots of different things that we look at there. One of the pieces was sort of how we can find area when it doesn't just perfectly fit one of our formulas. Right, what do we kind of need to divide up and use? So let's pretend that this right here is sort of our side wall over here. okay, and decide that I want to paint this, which is a true statement because I hate these wall colors, but whatever. What color should we paint this wall over here?
Pink.
Black.
Not pink, I hate pink.
Black.
No, that's too dark.
Blue.
How about teal?
Okay.
I could go
A
teal.
light gray.
A light gray.
A light
Light
gray.
gray? Okay, we'll do light gray on another wall and teal on this wall.
Jeez, we got Justin Taylor over here.
Okay, so we're gonna paint this wall. I need to decide how much paint I'm going to buy.
I don't know.
Okay, I could go to the store and I could just randomly buy some paint.
That would be a good idea.
Okay, but I could end up with way too much or way not enough.
Yeah.
Okay, so instead it might be wise if I know, right, because the paint can tells you how much surface area it will cover. Okay, so when I'm painting this wall, do I actually need to paint this entire wall?
Yes.
No.
No, what do I not need to paint?
The
Oh,
whiteboard.
The whiteboard, right, because I probably still want to be able to write on the whiteboard.
Yeah.
I know.
Okay, so when I'm deciding how much of this wall I need to paint, I need to calculate the entire surface area of the wall, except,
For the whiteboard.
all is apparently called, I need to subtract off the area of the whiteboard, right? Because that doesn't need to be painted. So that's that same idea that we're looking at up here, right? I want to find the area of the orange stuff, right? For lack of a better word. So I want the area of the orange stuff. So just like over here in painting this wall, right? To make this wall happen, we would find the area of the whole entire wall. What would we do next?
You found the surface. Oh.
You would find the area of the whiteboard.
Find the area of the
and then
whiteboard.
Subtract the whiteboard from the area.
And then we would subtract them. So that's exactly the steps we're going to have to go through up here.
Why did I think this was so hard last year?
Well, right, so this is sort of where my students will say to me, wait a minute, that felt so overwhelming last year, and it seems way easier now, right? Often when we hear things multiple times, okay, they start to get easier. Okay, so let's go through and do this process. The first thing we're going to have to do is find the area of the big rectangle. Okay, so we're going to take length times width. I already see some of you running with it, right? So we're taking 3x plus 2. Seems like we okay. And a 2x minus 1. We're doing this length, times this width. And we know how to multiply these two things, right? We're distributing. So we should be saying a 6x squared minus a 3x plus a 4x minus a 2.
Wait.
So that gives us a 6x squared plus a 1x minus a 2.
Oh,
Okay, then we set our next step, right? Just like over here was to find the area of the dry erase board. So now we're going to find the area of the smaller shape. That's going to be step 2. So let's see, I'm going to do these two, an x plus a 4. Does it matter if I put the x plus 4 first or if I put the x plus 1 first?
no.
No, right? Order of multiplication doesn't matter. Your work might look a little bit different, but you'll be the same in the end. Okay, so that gives us an x squared plus a 5x plus 4. What did we say the last thing was that we would do?
You have to subtract.
We would subtract. Now, you can't subtract in any order because then you'll get negative area, right? You need the big minus the small. So you have to subtract in that correct order. I'm actually going to write this step a little bit off to the side. Right, so we can just sort of shift this area underneath over here. So we have x squared plus 5x plus 4, and we need to subtract them.
Yeah.
Now, what did we say we would do when we subtract?
You would add
We would add the opposite. So we really want to change this to addition
and make them all no.
and change the sign of everything following it. This is a negative x squared, a negative 5x, and a negative 4.
Yeah.
Okay, so a 6x squared and a negative 1x squared will give us a 5x squared. A 1x and a negative 5x will give us a negative 4x. And a negative 2 and a negative 4.
Negative 6.
Negative 6. So this would be our final answer. This would be the area of the orange part.
That was a lot.
Now, it's a lot. It is. But it's nothing new.
You're gonna give us like 5 of these problems.
No, I'm not. I promise. Okay, I'm trying this out. Let's see if this works because I'm trying to figure out if it will do it after it falls asleep. GoPro, stop recording.